I know, I would rather be asleep right now. So my name is Iliyan. I lead Project Treble at Google, which is, of course, our attempt to address the issue of version fragmentation within the Android ecosystem. I'll talk real quick about the nature of the problem and why I should care, and about the two components to fragmentation, namely the user space part of it and where it concerns the Linux kernel. And I have a bit of a, hopefully, juicy announcement to make with regards to the kernel. And then finally, I'll talk about some of the early results that we see as a result of our work. So what's the problem? That's the problem. This is from our own chart on AOSP. AOSP, for those of you who may not know, is the open source version of Android. Well, you see that we just released Android Oreo a few weeks ago, and it's not there yet. Android N Nougat is a year old now, and it's still only at about, I think, 15%. This is what we refer, and things are, you can see Marshmallow and Lollipop all the way to Jelly Bean still being sizable fractions of the Android ecosystem. This is what we call the Android version fragmentation, and this is what we want to address. Of course, Android is a Linux distribution. Where the kernel is concerned, things are looking pretty dire as well. I actually don't have the data I just slapped some Linux version numbers in there based on my memory. Google, to this day, until Project Oreo, until Oreo and Project Treble, Google wasn't collecting stats on the kernels that Android devices run. We just don't know. So I'm just going off of memory based on my work on Nexus and Pixel devices. So that's pretty sad, right? We want to change that too. Ish. All right. As to why care, you could legitimately ask, why would anybody want to get a newer version of Android? You have to assume that the newer version of Android is something that the end user wants, and to this day that has been the case. But these sort of four categories are what I wanted to, apologies about the typo. This was at midnight last night on the better security part. These four categories are what I wanted to call out. Obviously, on the right-hand side, you can see sort of who cares about. Everybody cares about faster device launches on the latest. Everything else, everything being equal, an OEM would want to be able to launch as early as possible in the latest release of Android. That's just a marketing plus for them. So anything that prevents them from doing so is something that we want to address. Easier device upgrades is sort of the sister issue to this, where if you launch more easily, then it should also follow naturally that you get to upgrade more easily a device that you launched on an older version of the operating system. Better quality, of course. One should hope that future versions of Android are better quality than past ones. And last but not at all least, the kernel part of this is what we really, really lag behind. And that's sort of one of the integral reasons for why we joined Linaro, the mobile group. I'll talk about that in one of the next slides. A grossly oversimplified version of what happens when somebody launches an Android device follows. First, we start with AOSP. What Google releases to the world is what we call AOSP. Does anybody not know what that means? I mean, I know what that means, but does anybody not know what that means? AOSP for Android Open Source Project? Okay. So we released AOSP at one point in the year, and it's just a bunch of projects that are largely divorced from any actual end consumer hardware. AOSP isn't necessarily able to run on a Qualcomm chipset or any other or anything else as it is. It lacks things that you would want to see on a consumer device. So what next happens is Again, this is simplified. What next happens is an OEM or an ODM adds a bunch of functionality that's missing to AOSP. This ranges from features that are missing in the code base themselves that one would need to launch in China, for example, but also includes, differentiation type features, something that would make a device a Samsung Galaxy or a Huawei device or a Sony Xperia. And of course, you need something to make this entire code run. You need code to make this entire thing run on the actual target. And so you add this adaptation layer for the actual SoC, and you qualify it to the actual device. And so that's sort of the oversimplified, beautiful picture of what an Android release is when it hits the consumer's hands. Of course, reality is slightly different from that. It kind of again, this is like midnight last night, so I'm a really bad procrastinator. So it kind of looks more like this and not like that. What the angry faces and the squiggles refer to is that these additions and adaptations, they're not compartmentalized, they're not isolated to where they properly should belong, they're all over the place. So for better or for worse, this image will stay with us for the rest of the keynote in the upper right corner of the slides. Why is that? Why is that? At the top of it, so this ugliness is why it is difficult to upgrade Android to new versions of itself, and why it's difficult to also launch. And the reason for that is you have these short product cycles. In certain places of the world, OEMs launch every 4 to 6 months. In many cases, Android devices have a short shelf life. They're more like accessories rather than something that you think of when you think of a high-end flagship phone. And so all of this forces everybody to essentially cut corners and to just get there to get it done as fast as possible, and so we end up accumulating technical debt. There's no single Android OS to update. As the simplified diagrams, I hope, sort of clarified, what runs on any consumer device is very different from what AOSP has. It's depending on the silicon vendor and OEM involved, there could be a delta of 1,000 to 5, 6, 10,000 patches. And that's a patch, so it could range from a line to thousands of lines. Because there's no single Android OS to update, you have to solve the updates problem on a case-by-case basis, as of Android before Android Oreo. And of course, SoC support is not universal. Silicon vendors are in the business of selling silicon, which is hardly surprising. And when they commercialize a piece of silicon to their OEMs, they want to move on to the next thing. And so what happens when you want to launch a low-end device on a piece of silicon that isn't as new as, that is as old as 2 or 3 years? There's no business incentive in the ecosystem for you to do that, because for people to support the latest Android on that old silicon. And of course, there are added QA costs, call center issues that people call when they're angry, when their update breaks their phone or whatever, OTA infrastructure costs, and so on. So difficult means expensive, and the way that we fix it, whatever we do to fix it, has to do with reducing costs to the major players involved, and that's the silicon vendors and the OEMs primarily. So this is what Project Treble did. Treble, so there are 4 squares on this display, and Treble refers to 3. I guess that's a nod to the British folks in the room. Pretend it's just 3. The Treble refers to addressing the issues where Google is concerned, where silicon vendors are concerned, and where OEMs are concerned. In order to get that done, we had to tackle sort of the issue on several fronts. We had to make some architectural changes to the Android platform to make that compartmentalization and that pretty picture more of a reality and the ugly one less of a reality. Some operational changes. We did a massive outreach with our major partners. I see a lot of Qualcommers in the room. We've been working with them very, very closely and yelling at each other a lot, I suppose. We want to converge that delta between AOSP and the consumer versions of Android as much as possible so that other companies don't have to carry this patch set out of tree. And we made some changes to the way that Android compatibility requirements are laid out, which I'll talk about later if I have time. So we first want to start by solving the SoC support part of the picture. We'll be going back to the pretty picture slowly, little by little. We want to get back to solving the SoC support. For us to do that, let me just take a quick detour and give you a quick overview of what Android looked like, what the Android architecture looked like before Android O, and then I'll say how that changed in order to accommodate this effort. If I go back to the previous slide, the space between the SoC sort of rectangle and the ugly above it is what we call the HALs. A HAL in Android is used to be a vague term that denotes the interface boundary between the piece above that is independent of the hardware and a major subsystem. So we're talking about the camera HAL, the audio HAL, Wi-Fi, telephony, and so on. Android is devices and tablets for the most part still, and these tend to be fairly standard in terms of the subsystem support that they need. Of course, things differ when you start talking about Internet of Things and Android Auto, but for phones and tablets, there is a well-defined set of subsystems. Prior to Android O, the implementation of the HAL, the implementation of the subsystem that is vendor-specific, that is either specific to a silicon vendor or to an OEM, lived in the same process as its client. So if you look at this diagram, you have an application that's talking over binder, and binder is, of course, Android's IPC/RPC mechanism to a number of internal services. These services would literally incorporate in them, via just loading shared libraries, the vendor components. The interface between them and those vendor components was never really formally defined, and it was really quite fragile even when it was. We never made a formal promise to our partners that what interface we defined for the audio HAL, for example, wouldn't randomly change from one version to the next. So that created a lot of difficulty in moving forward where our silicon partners are concerned. So what we did was we extended with Oreo. That's the biggest change sort of in terms of engineering effort that we did to Android for O. We formalized the division between those HALs, those subsystems, and their clients by making them each their own server, their own daemon, if you will, that communicates with the clients over binder again. We made a number of changes to the binder kernel driver and to the supporting infrastructure in Userspace to make sure that this is fast, right? Because when you're talking about camera, you could have a scenario where 240 frames per second while recording video, that needs to work as well as it did before, or we failed. So it is this division and formalization of the interfaces between the HAL components, between the HAL interfaces and the framework on top that underpins all of the work that we did. With this distinction, we created about 60 formal interfaces. And when I say formal, I mean we created an interface description language that has the notion of versioning, semantic versioning with major minor versions, that auto-generates code to Java and C++ that then wraps the old code around it. And it is this versioning that is now SFO enforced via a set of tests that we call the vendor test suite. Those of you who work more closely with Android would know that CTS is what defines Android. It is, if you want to ship an Android phone, you want to pass CTS. CTS is the set of tests, about 1 million of them as of Android O, that hammer on the public APIs to make sure that whatever you did when you were launching your device, that these APIs can support the actual applications. What CTS is to applications, VTS is to the Android framework. And that's enabled by the formal division that we did between the two components. The HALs are one of the three components that we cover with VTS, the other one being the kernel, because Android never pretended to run on anything other than the Linux kernel, and so it obviously talks directly to the kernel. It's not always intermediated by a HAL when it talks to the kernel. Like you make a syscall talking directly to the kernel. So the vendor test suite is what now enforces this division. And so now we got to the point where we can put back the AOSP bubble on top of the interface that we've defined. And that's great, but as I pointed out, that's not a consumer device. Nobody launches AOSP phones. You cannot. They're not a final product. Still, we use the AOSP on top of the vendor interface concept in order to drive further convergence. In order to tackle the AOSP, and one of that is in order to tackle the AOSP delta, that is the delta between AOSP and the consumer versions of Android. What we do for that is we kicked off a bunch of initiatives to basically take our partner's code and upstream it, check it into AOSP. Some of it happened with Android O, but most of it is actually ongoing work that we keep talking about and actually working on for a change. Upstreaming, though, will take time. It's not something that we can complete in one release. It's not something that we can ever complete in a very real sense, because you cannot expect for a Samsung or a Huawei or a major OEM to contribute everything to AOSP. Some of this is differentiation for them that matters to them, that is tied to their business, to their business's bottom lines. So what we cannot upstream, we want to create formal interfaces for value-add additions to plug into AOSP properly, but that's a longer-term work. Because that's a longer-term work, what we essentially did with Treble is this. We have this formal interface between the components defined, and we now, due to the compatibility requirements that are in place with Android O, we now require that every OEM that launches a device with Android O be able to run the unmodified AOSP system image that we actually generate for them on top of the BSP given to them by the silicon vendor. This may sound a bit hand-wavy, but it is a major accomplishment in the ecosystem. It has never been possible for that to happen. And while that's not the same as being as an end product being able to run on the BSP, on the lower piece of this picture, it is like 80% of it. And for the remainder, the fact that this is now a requirement means that we create a disincentive for anybody working on an Android launch to diverge too much from AOSP. And we hope to capture what is meaningful again to our partners and isn't proprietary by upstreaming it to AOSP. I already talked about the compatibility requirements in the previous slide, so I'll just skip to the next one. This is an important one. All of this work that we did for O, we had to do within one release for a number of reasons. One of them is it takes time for new Android releases to proliferate, to trickle down to the rest of the ecosystem. And so if we take too long, if we take more than one release, we won't start seeing the benefits of this to accrue to the ecosystem for years to come. And then we run into the issue of everybody's attention span, right? We need to solve this, and we need to solve it now. And the fastest that we could tackle the biggest part of the problem is one release. So that we tried to do, and I think that we pulled it off. Now the kernel. Now with the kernel, you see a kind of fragmentation that sort of mirrors Userspace. You all know how kernel development happens, so I'm not going to go through that. But I will point out that all Android devices out there, basically, are based off the LTS kernel, the long-term support one. Well, the problem with LTS is it's only 2 years. And so by the time the first devices on an SoC hit the market, you have maybe a year, if you're lucky, of LTS support, and if you're not, it's over. It's just how it is. A silicon vendor has to make a decision to commercialize a piece of silicon on a given kernel version, and they cannot change that late in the product cycle. And that's like 1 year before you see the first device, or whatever, some amount of time before you see the first devices ship. The end result is that LTS cannot cover the device's life cycle, and LTS is where all of the critical bug fixes from upstream trickle down. And so with today's situation, what Google wants to see with our partners is once the device is launched, it gets upgraded 4 times to a new Android version. That's basically the lifespan of a phone. But you get lucky if you get one of these. So that's my hopefully juicy tidbit here. Greg Crow-Hartman has given me permission to announce this here. He will extend LTS to 6 years, starting with kernel 4.4. And of course, a lot of this is underpinned by our joint work with Linaro, which is part of why I'm here. A 6-year LTS kernel, or we don't have a cute name for it, XLTS for extended or ELTS for extended, but 6-year LTS is really an amazing feat that we have to pull off if we hope for any of our devices to get all the security fixes, all the bug fixes from upstream that are available. So this is where the kernel is concerned. The kernel slides are shorter because the kernel is always easier than Userspace. All right, so I'll talk about quickly about, how am I on time, by the way? Yep. I'll talk quickly about stats, sort of stats and results. I mentioned there are about 60 Android subsystems that we created formal interfaces for using this interface definition language that we call HIDL for HAL IDL. And they're all converted to it. Some of these subsystems didn't even have a formal interface to speak of. So we had to create that. And that's now in, all of this information is, by the way, on AOSP. We published all of our documentation for anybody for any system integrators. And I, of course, forgot to include a link here, but it's up on AOSP. Just Google AOSP Treble Oreo. The work spanned about 300 authors, and that's the ones that I can count within Google. About 3,000 files, 20,000 commits, and about 1 million lines of code added or changed. This is really within the span of like 4 to 6 months, because the way big companies work, project gets approved, and then you start twiddling your thumbs until you get the resources, and then everything comes crashing down towards the tail end of the schedule. So this is really quite an accomplishment when you take that into account. With respect to our partners, we worked directly with Qualcomm, MediaTek, and Samsung, and also Huawei, Motorola, Sony, and LG to get them going on Oreo. We have on-site teams in San Diego, Taipei, and Seoul to help with this engagement, and a number of forums to just keep repeating the message and make sure that everybody's on the same side. In terms of launches, you probably know that Sony already announced the Xperia, which is on Oreo and fully Treble compliant, and the flagships from Huawei and Samsung will also be compliant with Treble when they release an O. From our major partners, of course, with Qualcomm, we've worked on 3 SoCs to convert them to Treble, and those will underpin a number of launches, one hopes. Not my place to talk about them. Ditto with MediaTek and HiSilicon. The HiSilicon and Exynos SoCs are obviously tied with Huawei and Samsung. As far as next steps go, we want to build on the 6-year LTS thing. By the way, this says 4.9. It should have said 4.4 because that's going to be the first 6-year LTS. Just pretend you're seeing 4.4 there. We want to build on the 6-year LTS thing with something that I call kernel unification, for lack of a better word. It's very hand-wavy. We are talking to all of our partners. Discussions are ongoing. But the general idea is that, as with Userspace, so with the kernel, you want to have the kernel on any Android device that launches to be downstream of 6-year LTS, but in between, you want it to also be downstream of hopefully a single SoC kernel, not 15 forks of it around the world, which is itself downstream of the Android common kernel, which is itself downstream of 6-year LTS, in any backports that we deem necessary for Google work. This is where our membership of Linaro and our work with Linaro will come into focus truly. It's 6-year LTS and this kernel unification effort, which, again, this is next steps. Nothing's formalized, nothing's decided, but this is kind of the goal. And there's more to do beyond the kernel, of course. There's the ongoing work with our silicon partners that just never ends. The kernel unification thing, better test coverage, that's important. VTS had 6 months to come into existence compared to CTS's 10 years of life. So VTS has a suite of kernel tests, a suite of HAL tests, but that's 2 orders of magnitude less than CTS. We need to keep expanding coverage, both internally and with our partners. And finally, but not finally at all, Android is Linux and Linux is ARM, and we want to play with Linaro to bring the ecosystem together. So that's it for me. Thank you for listening. If you have any questions, I'll be around. I'll be happy to, yeah. I just don't know if that's the format that you want to.
We can take 1 or 2. Anybody have a question, 1 or 2 questions? I mean, this stuff is very relevant to a lot of people in this room. Some pretty interesting. No one?
No, not quite the data center keynote you were probably hoping for, but Google has data centers too. They're just, I don't work on them.
No questions?
All right. So, are you going to extend it for your data centers? Why wouldn't you want XLTS for data centers as well?
I'm sorry, I didn't quite catch that.
Why wouldn't you extend it for data centers? LTS, would this be something that, being serious here, would Google support XLTS for data center?
Oh, for the data, well, I mean, LTS is LTS. A data center is, we are going to make, let me talk a little bit more about 6-year LTS. Greg Crow-Hartman, the LTS maintainer, is committing to do that, not because of Google or Android or Treble, but because everything is on LTS. It's not on upstream. And 6-year, he'll announce this at kernel.org following this keynote. So it's 6-year LTS. It's there for the taking for anybody who can. He won't de-emphasize x86 over ARM or anything like that. It's the kernel. So, but I'm happy because Android stands to benefit from that, right?
So I think what you're saying is 6 years. You get 6 years LTSs for everything.
For everything,
Not
yeah,
just for
yeah.
Android. Android's going to take advantage of it, but certainly other areas and other applications of the
absolutely.
kernel can also all take advantage of it, just like they take advantage of LTS today.
Yeah, you could imagine that IoT devices would benefit even more from that. Absolutely, yeah. Yeah.
Thank you so much, Iliyan, for coming here today and sharing that with us. We really appreciate it.
Thank you, and thank you for listening to me.
That was terrific. Thanks a lot. Thank you. Okay, so today's ARM Data Center Day, as we talked about earlier, and ARM Data Center is all about innovation, right? In the data center.